Hey, this is Bill Trombley from Trombley Tool in East Troy, Wisconsin. Today we're going to talk about different forms of shrinking. We've touched a lot on the use of thumbnail dies. Today we're going to talk about machines that are the Lancaster, Eckold kind of machines, Marchant machines that we call grab and shove style. So a grab and shove, if you look at the dies here in this machine, this is my Eckold kick shrinker here. You know, when I actuate the pedal, the die comes down and it pushes the material together. Same thing on this Marchant style machine, right? So this comes down and that pushes and engages together. I also have this Eckold machine here, which is pneumatic, and then I have an Eckold Piccolo here. This also is a grab and shove. So online, there's a lot of debate about which side of the fence are you on, right? Do we go grab and shove style machines like these, or do we use tuck shrinking and thumbnail dies like we had shown earlier? When you're new to metal shaping, you'll quickly realize that shrinking is the most difficult of all of the processes. You know, bending and changing the form of the panel is easy once you wrap your head around it. Stretching is super easy. You know, a hammer and dolly, man, you're stretching like crazy. When it gets into the shrinking part of it, it becomes the most challenging for everybody. You know, but it's highly critical because it allows us to develop shape in panels. If it was a panel that needed to be shaped, could I do it only with stretching? Sure. Problem though is if I only ever stretched the center and never shrunk the edge, then if it had a lot of shape in it, I could run out of material thickness in the middle, right? So by shrinking the edge, I can gain thickness to be able to make that work. So just stretching is not always a good solution. You know, for a lot of shaping stuff, you need to know how to shrink. Now, very early on, the easiest way to shrink, and the way it was been done for many years, was hammer and stump style. You know, this is a curve cutout on my very mechanical looking stump. You know, why don't I have a wood stump? Because I get all this other stuff. What do I need a stump for? But you can see here a tux form, you know, and with a teardrop mallet, and I can create the shrink. But what happens? Guys go, well, I don't want to do that, right? So, you know, my first progression was a Lancaster hand style shrinker. And then I eventually traded up over time and sold that, and I got a Bailey kick shrinker, and then I sold that, and I got an Eckold kick shrinker, right? So it was this natural progression, each time allowing me to gain the ability, the horsepower needed to be able to shrink. And this was long before I knew about thumbnail die shrinking. But there's two different camps on it, right? I've been pro thumbnail die shrinking. I've done a number of videos on it. I show how the process can be done. There are people who are anti that. You know, just get an Eckold machine and that's all you would need. You may look at it and go, man, you know, Trombley's wealthy. He's got all this equipment here. No, Trombley's extremely lucky. Several of these pieces of equipment is from my friend William that I talked about in the last video down in Kenosha. You know, he bought this stuff at auction and it was just sitting in his hangar, so he's allowing me to have it and to be able to use it. You know, it's basically like I'm permanent loan here. And another thing is an airplane guy, which is really like super cool, is my Eckold kick shrinker, or Williams, I should say, came out of Douglas Aircraft out of Tulsa. That's awesome. This one here, this Marchant, and now I say it's a Marchant, and guys go, Marchant never made fabricated ones. That's true, it's a Marchant style. If you go into the metal shaping history books, there's a whole volume series on that. I think Bill Longyard was involved with development of that book, and then there's another fellow, and sorry, the name escapes me at the moment. They talk about how some of these were fabricated machines, and that's what this one was. And this one actually came out of Rockwell, out of Palmdale. And you research Rockwell and Palmdale, that's where the space shuttles were built, which is pretty cool. My Eckold here, the first Eckold that I had that was like this came out of a NASCAR team. This one, I was able to sell that one and then get this one that had the pneumatics on it and everything. This came out of Toyota Truck, out of Charlotte as well. I think it was their truck racing series. So that's pretty cool. I mean, if you're into history, it's like piles of history here. My Piccolo's from France. That's too is cool. We don't know the history of where in France yet, but you know, I just like that kind of stuff. So anyways, back to my point. So you have the grab and shove style equipment. Does it work? Sure. If you look at the very early on, you know, my Lancaster style machine had serrated jaws. And this is I think a J&S tool design with the heavy serrations in it. You know, is that okay? In steel, it's okay. In aluminum, it'll cause what we call stress risers. And a stress riser is a fancy word for a perfect location for a crack to develop. So we stay away from these. You know, I found these extremely cheap. Made a stem to put it in my Pole Max. Can you use dies like this in a Pole Max? That's one of the questions that pops up. Not very well. In my nibbler medium, it worked. And the reason why is my nibbler medium, I had a variable frequency drive, a VFD on it. And I could slow down the RPM, the reciprocating motion of it, where I could run it slow enough and it would work. And that's actually why I have these. If you run it in a Trump machine, I can't run the RPM low enough. And what has to happen is this has to happen to come up long enough for the die to reset, to come down and re-grab the material. And if it's pulsing too fast, it just isn't effective. I think the Eckold Piccolo machine on mine, I think, is around 350 hits per minute. I think I saw that in their paperwork. So RPM becomes critical. So that's why you don't see these as options to buy for Polmax machines. It just doesn't seem to be a good, effective use for it. So you might have it and go, well, if you're anti-grab and shove, why do you even have these? You know, there's a lot of money sitting here if you added it up. And the reason why is if I have like an airplane rib with a flange on it and I have to shrink the flange, very efficient, right? You can't beat it. You can't get thumbnail dies in there to do that. That's mainly what I use these for. Eckold, the benefit of an Eckold machine like this one here and my Piccolo is plastic tools, right? So these draw faces are plastic, called Nomar dies. The benefit of a Nomar is it doesn't mark up the surface. So I don't even have any marks in the aluminum. On steel dies, like in the Eckold machine, you'd have to stipple the die, which is a textured surface, looks like sandpaper. But that too will imprint in the aluminum, and then the only way to fix it is you'd have to die grind that off. So another benefit of this the Eckold system is, you know, these jaws here are called beak dies. They allow me to get into a hat channel, tighter profile areas, which is very common with the airplane stuff. And you just run into those challenges if you're going into some of those other kinds of equipment. So you can see that all of a sudden you kind of start needing more and more different options if you're trying to do the technical work like what we're doing, where we're getting into these funny profiles and extrusions and hat sections and tight areas, and then I got to maintain surface finish. I can't put cracks in it. I can't put stress risers in it. And this kind of stuff, all of a sudden, you know, you need more options. Does a car guy need to have these options? You need it to a certain extent, but maybe not quite to the level that we're taking it here. It's just a different world. As you can see here on this table, and I'll take you over here and look at this, and I hope you don't mind me carrying the camera around like this. You can see that I have this divided up into two basic sections again. So, thumbnail dies like we had shown in the past. You guys seen all that stuff. And then here you can see the grab and shove style dies. A lot of these are Eckold dies. So this is a radial shrink die. So this shrinks in both directions. So like you go out in a high spot in the middle of a panel, and you can shrink with that. Shrink dies that are smaller diameter. Plastic Nomar dies. So that's a white plastic that's there that you would use for shrinking. Very effective, works well. These are the smaller dies that I would use in the smaller Eckold machine, shrink dies. And then here are extended dies, shrink dies, like that would go in the Eckold kick shrinker. I'm pretty lucky to find that stuff. Eckold stretch dies. All right, so this would come down and spread apart and stretch. Do I use stretch dies? No. Why? I have linear stretch dies. So I'll use a linear stretch die in a power hammer or in my CP plenishing hammer. Or I will stretch it in an English wheel. And it's compressive stretching. And it's very efficient. And I can do it in grades of aluminum that are very sensitive to cracking and cause no cracks. That's a huge benefit. If you're using those stretch dies like in an Eckold kick shrinker, especially in aluminum, it's sensitive to grain direction, it's sensitive to grade of materials and that kind of stuff, and it's easy to split the material. So in my world, it just never happens. There's just never been a reason for it. I've tried them because I had them, and let's see how this works, and just so I know, and they're saved in my drawer. And if I had a project, you never know what you might come across, and you have to come up with this combination to get this to work. And that's the benefit of having them. So otherwise, they sit in the drawer, and they're there if I ever needed it. It's just not something that we get into very often. I haven't yet. So you can see here, grab and shove mentality versus thumbnail die technology. A thumbnail die, and we talked about this, like I said, in a number of videos. But it seems like some people still are wondering, well, why? Why would you have that? And how do you know it'll work? Well, thumbnail die lower, tuck from a hammer, right? It's the same. It's the same process, and that's beneficial, right? Are both processes the same when it comes to the material? And I want you to think about this a little bit and help try to maybe drive this home. It's about the matter of, there's several things, but one of them is how much energy does it take me to shrink the material? Now, if I take this plastic teardrop mallet, doesn't weigh very much, right? I can go along on my tabletop here and I could go tap, 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 and I could shrink out this tuck, right? Pretty efficiently as well. Shrunk the tuck. How much energy did I impart with this? You saw me. I wasn't swinging like a gorilla to swing this thing. This thing isn't even that heavy. It's plastic with a wood handle. You know, does this weigh a pound? I don't know, maybe. You know, a wood tabletop, and it's tap, 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 and it shrunk out. You know, if I'm doing it in the wood stump and I'm creating the tuck, you hit it really good in the right spot, you put the tuck in it, and it's just tap, 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 and you shrink it out. It's a very efficient way of doing it, and I'm taking the material and I'm still pushing it together, right? Very low energy. Thumbnail dies is the same. And you go, well, how could that be? You know, I got this big, huge machine and I got all this power. Well, this is the sample piece we did the other day. You know, 2024-0, and you saw me thumbnail shrink that. You know, but here I am, I'm doing it, holding it with my hands, right? So the amount of horsepower that I'm putting into it is enough that it isn't ripping my fingers off, right? I can easily push it in and push it out, push it in, push it out. It doesn't take a lot of energy to get the material to go together. And you go, wow, you know, what about all this other equipment? Well, think of a Lancaster. Now, I don't have mine here, the Lancaster shrinker, but you know, if you've been in metal shaping for a short amount of time, you've seen them. You know, you can get them from Harbor Freight. But it's got a handle on it about that long, right? You got to clamp it to the tabletop, and it's a big, huge steel-built C-frame, and you got to push down on it with your body weight to get the shrink to occur. If I go to this Eckold kick shrinker here, which are awesome machines, and you know, I love vintage cast iron stuff, but here this thing probably weighs 500-600 pounds, right? And I got this huge foot pedal at the bottom, this big pendulum that I got to move to do this, and I'm taking the biggest muscle in my body to move the pendulum. Move this camera back a little bit, right? So here I got to push down on this to get this to move, and I'm using this big muscle to do that. You know, same thing when it comes to this Marchand. You know, this machine is lighter than the Eckold, right? But I'm still using the big muscle in my body to do it, and a big pendulum weight that's on there. If you're using a kick shrinker properly, you're not using it to force the material with the pedal. What you're using your foot to do is to get the pendulum to move, and the idea is you're supposed to let the inertia of the weight shrink the panel. Now you can look at this Eckold here. Now this Eckold machine, this Piccolo, weighs several, maybe 2,000 pounds. That's probably a little high. I'll try that camera angle. Okay. So in this Eckold machine here, you know, it weighs over 1,000 pounds, and I have this big huge flywheel that's inside, and a big electric motor on the side. It's like a 3 horse or 2 horsepower electric motor. To be able to do the same thing, it grabs the material and shoves it together. So it takes a lot more energy to shrink with these. You maybe go, well, you know, who cares? Well, valid point, but it is different. And that's important to know. So, you know, I have this Eckold machine, and people have said, you know, what do you think? And I've said that, you know, the problem with these machines is they can make you a bad metal shaper. And that really gets a lot of people kind of upset at that. But it's true, and I'll show you why. So here, this piece here is another piece of 2024-0, 50 thousandths, 8 inches long, just like what we did in the tuck shrinking video. So, and what we're going to do is we're going to shrink it in this machine. saw right away what happened. I had the sheet was flat, boom, instantaneously reverse direction. Why? I didn't roll the form in it like I was supposed to. That's not the point of it. Now look at how dramatic the shrink was. Guys are going, oh yeah, man, that's freaking awesome. You know, look at this. I took all that stored energy in this machine and whoa, I shaped it and I shrunk it like a madman. What did I do? I put a boatload of stress in the panel, right? Now, for guys that know, you're going to watch that and go, dude, that's not how this is done. And I understand. And we're going to talk about that in a little bit. But if you go to metal meets, and I've seen this happen, guys look at this and go, man, you know, these things, if I just have one of these machines, I could wad up parts, right? And we've seen, there's the classic story that's always been thrown around. We're at a metal meet. They had an Eckold machine there that's the really big Eckold machine. And you see the guys go over there and they'd fire it up. And they'd bring the dies down and it sounded like a forging press. The thing would come down and go whoomp, whoomp, whoomp. And they'd take the material and just go wah and wad it up. And guys are like, look at that. You know, and they'd put it on their buck, all happy. The next day they come back and the part's not touching the buck, it's up a little bit. And they actually get upset and they're going, you know, who's screwing with my parts? No one's screwing with it. The day after it's up even more. Why? You cause so much internal stress in the material from this process that the stress is actually higher than the yield strength of the material, and it's yielding itself from the stress. So it's ridiculous, right? So that's the problem. These machines, they're easy to get like all Mr. Spinal Tap on it, right? We should actually write on there Spinal Tap, meaning I can turn the machine to 11, right? You just crank it to 11, wad up your material and go. Okay. Is this the end of the world? You know, is this junk? For me in my world, I'm not a fan of it. But you could go, well, you know, you're an airplane guy and you guys are weird anyways and you got all these rules and regulations, whatever. Yeah, I get it. But is this non-salvageable? And here's the important thing to think about. What about we put it in the CP plenishing hammer after it was shrunk? Now what? Took the stress back out of it. So why? What's going on here in a grab and shove versus thumbnail dies? Well, if you look at a grab and shove style die, the effective area on an Eckold die is about 100 thousandths, which is about 2.5 millimeters. So each time it comes down and it grabs the material, which is in metals, it's a crystallized structure, a crystalline structure. You're taking the material grains and you're taking a few grains over a short distance and really trying to move them a lot. And for guys that have engineering backgrounds or especially metallurgist guys, you're going to listen to this explanation and go, dude, that's way too simple. And you're right. And it's simple for a reason. You know, we're trying to make this so that people just don't click this off and go, oh, there goes Bill again into all this fancy science stuff. But it's true, right? So you're trying to take a material over a short amount of distance and just push it together. And so you're taking a lot of grains and you're trying to move them. If you take a set of thumbnail dies, now these are the thumbnail dies that I used. Actually, that's not it. This is the thumbnail die that I used in the last video presentation with shrinking in the pole max. Now if I take this piece of paper and I mark over the thumb area, like that, and I pull the piece of paper out and I measure it with my fancy dancy 6-inch scale, which I always have in my pocket, the arc length, so that's the geometry term of this distance going across here like this, is 1 inch. So what I'm doing is I'm taking and I'm creating the shrink over a much greater area, which means I'm asking each individual grain to move less. Why is that important? When you start spending time with like guys like Faye Butler, who is hardcore on material science, and this is where I learned a lot of this information from. Faye recommends this book, Metallurgy 5th edition. He's got it on his website. Now you guys might be going, dude, I don't care. Well, just bear with me for a second. On here you can see the rolling process of material in the elongation of grain. So what this is saying is the more I elongate the material, or the more I roll the material, the more I elongate the grain, the harder it becomes, harder in strength. The longer the elongation, the harder the material is, the higher the strength of the material. What happening is what dies like this, is it's taking the grains and greatly elongating them. That's why the material gets hard. The thumbnail die, because it's over a much larger area, is taking each individual grain and elongating it less. And that's how come it doesn't get so hard. So then you go, what is causing in here that alleviates this? That appears to be a little bit of an unsettled unknown. And here's why. My hypothesis is, and I could be totally wrong, but to test it, I have a friend of mine, name's Mike, PhD Mike. He's got a PhD in metallurgy. When I met him, he's at UW-Madison. He's on to Sierra Space now. I need somebody like him to think about this and, in amongst his time when he's trying to do all that space stuff. But my hypothesis is what's happening here is the grain has been drawn out and elongated, and when I hammer it, I'm making it rounder again. I'm radially stretching out the grain. And by doing that, it's taking the length out of the grain, making the panel soft. I proved it here before your eyes. So what's the point of all this? So am I saying never own an Eckold, never own any of these kick shrinkers? Well, there's two things to think about, and we'll finish up. If you look at these dies on the table, as an example here. So I have on my table plastic shrink die. That's a $7,900 die. This die here is a $2,000 die. The one in the machine is about a $2,500 die. Those extended beak dies that were in my pneumatic one are $5,000 dies. And then you haven't even bought the machine yet. Machines are expensive when they say call for the price, right? They're stupidly expensive. Is that cost prohibitive for most? Yes. Are those prices, those would be the prices if you bought it new, right? So could I buy these online cheaper used? Yeah, that's how I do it. Was it, dirt cheap? No. Versus my 2-inch plastic thumbnail die here, from Stan Fulton, pretty cheap. What did we just say? Around $100. So all of a sudden you can start weeding into these things here and go, cool and all, but do you really need it? for me, you might be looking at it going, why do you have it? I'm the luckiest guy you ever met. And if you, that's how it was with my Eckold machines, that's how it was with this stuff, that's how it was with the other kick shrinkers and whatever. It's just been pure luck and knowing people and developing friendships and whatever. And that's how I was able to get to this position that I'm at. So, the last thing before we wrap up is, so what about that Eckold machine over there in the corner, this Piccolo? You know, that has all this energy and it's just uncontrollable and it just wads up. Well, let's go look at that. So we're going to go back over here. And I know some of you guys are going, this video technology that Trombley's using stinks. Well, this is the video technology that Trombley likes. So what we're going to do is the same piece of material from the demonstration from last week. Thumbnail die this, shrink this, and we're going to go over here and we're going to shrink this time. But what we're going to do is we're going to do it for 2 minutes. Now you just saw what happened, right? You guys are going, you're crazy. Well, just bear with me. So. Now what happened? Equal amount of shrink on both sides. Went for the same duration of time as I did with the thumbnail dies in the Pullmax machine. So I made it equal in duration of time. So what did I do? I backed off on how much this thing squeezes. What did it do to the material? Nothing. Didn't change the stress. So what's the point of the story? Don't get all Mr. Spinal Tap and go to a number 11 on these machines. Now you may look at that and go, well, I don't have a Piccolo. I got a Lancaster, or I have a kick shrinker, you know, a Bailey industrial kick shrinker and stuff like that. Yeah, well, same effect. If you watch guys that are experienced metal shapers that have kick style shrinking machines and they're using that for their shaping process, you watch, it's a controlled methodical process going all across the panel. You know, and they will shrink here and then they'll work their way in and work their way in, but they're not going to kill mode, right? They're not standing on the pedal just trying to wad up the material. So it works. It's the same premise on both. It's just that here it's so much more dramatic because they have so much more stored energy in the machine. So now you might see why it's a difference. And you can see why both processes get us to the end result. One of the things that people have claimed, or that they like about this, is they say if you're using a grab and shove style, you don't need to have technique. That you can have an amateur starting out doing this and they're shrinking and they're effective. You're right. Sorta. If I turn this up to kill mode and go to 11, that amateur will have so much trouble he won't know what to do with it. Right? If he doesn't know how to layer his shrinks, he won't know what to do with it. Also, that amateur had to, get a second mortgage on his house to be able to pay for this stuff. Thumbnail guys. If you don't know what you're doing, or is it challenging? Yes. But all of this, you got to get an education. Get your education, invest your time into that before you invest your time in the equipment. And that'll save you a lot of money in the long run, and it'll save you a lot of learning curve and everything else. So, hope it makes sense. The video quality is what it is. I'm trying to do this by myself with a video on the tripod. So, and just bear with it. Think of the content, maybe not so much of the actual camera angles and stuff like that. So, thanks, like and subscribe, tell all your friends, and have a good day.